Hello there. My name is Tim Tague, and I'm going to discuss a little bit about problem three of the midterm three. So, about the business problem here, the company is experiencing significant loss of their share price, and the company is trying to figure out why. Company's Communicorp trying to figure out why their company is struggling and what has been changing differently. They've been producing products well, so productivity is not the cause of the issue. But what they turned out was that it was a simple communication error between departments in that um, across departments they weren't communicating properly on what was being processed, what was being developed, what was being marketed effectively, and that was the issue. So Mr. Hamilton, the CEO, I believe, decides to install an intranet system um, to increase communication across departments and to help, yeah, streamline communication and improve their um, increase their stock price and improve their revenue. So this intranet, there are a couple decision factors that come with installing this intranet. First off, um, when to install it, in what departments, and what type of servers to buy to support this intranet. So Mr. Hamilton decides that in month one, he just wants to educate people on the intranet. Month two, he'll install it in sales. Month three, he'll install it in manufacturing, so on and so forth. You'll see these details later in my code and problem statement. And there are also four different types of servers that support different amounts of people, different amounts of employees, and cost a different amount. As well as in certain months, there are discounts supplied by these server companies. 10% discount for supplied by one company, 25% discount by another, but only in the first couple months. As well as there's a budget constraint of $9,500 that can be spent in the first 2 months, and also the manufacturing department requires one of the three strongest servers. So like I said, there are four server types, so manufacturing needs one of the three stronger types. So for the first part of this problem, we are evaluating it on a month-to-month basis, and in each month we are formulating a separate linear programming model and deciding how to minimize cost for that month. And so I guess I'll explain kind of month by month my thought process, and how we went about this. So in month one, as I mentioned, there are zero people that need the server. It's just an educational period. So also in month one, so here are the four server types, the cost of each type, and how many people they support. I just wrote these here so we can see it all as we're discussing the problem, and for me when I was developing the linear programming model, so I could have this information. Um, So in month one, as I said, we need to support zero people. It's an educational month, is to teach people about the internet. So I formulated the model, but as you'd expect in a month by month problem statement, when we're just looking at this month in a vacuum, we're not going to buy any servers. So you can see this code. We're minimizing the cost. This is the cost of the first server type, cost of the second server, cost of the third server, cost of the fourth server. So you can see for the third and fourth server, there's a discount applied, subject to the constraint of the amount of people that the servers can support. So the first server can support 30 people, second server can support 80 people, so on. It needs to be greater than or equal to zero, as we're supporting zero people. As you would expect when we run problem 3A month one, we get, it's running, server with objective value, or solution with objective value zero. We don't buy any of the servers, as in month one, we are supporting zero people. When we move on to month two, keep in mind in month two, we now are supporting, I think it's the sales staff. Yep, 60 new people of sales. It's the same exact minimization function. The cost of each server type multiplied by the server variable. So X1 being the standard PC, X2 being the enhanced PC, X3 being the SGI, and X4 being the Sun. In month two, there is also still a discount on the SGI and on the Sun. So 10% discount brought this down to 9,000. 25% discount brought this down to 18,750. So we're minimizing this cost function subject to the constraint being greater than or equal to 60, as we need to support 60 people in month two. In a vacuum in month two, we're supporting 60 people. So this is the number of people that server one can support, number of people that server two can support, etc. When we run this, we are going to get, you'll see in a sec, that we buy two of server type one for a cost of 5,000. So it's running. Yes, we buy 2 of server type 1, so 2 standard PCs for a total cost of 5,000. This supports X1 equals 2, supports 60 people greater than or equal to 60. For month 2, we are set. Let's move on to month 3. In month 3, there are 200 new people, those new people being manufacturing. Manufacturing needs one of the 3 powerful servers. We're going to have an extra constraint here. Again, here's the minimization function. Notice how now there's no discount being applied for server 3 or server 4, the SGI or the Sun. These are now valued, or these now cost $10,000 and $25,000 as the discounts were only for the first 2 months. So here's our constraint to support enough people. We need to support 200 people. Again, this is in a month-by-month basis. We don't care that we already have those other servers supporting those 60. We now need to support 200 in this month. What should we buy? Again, here is manufacturing needing one of the 3 powerful. This is the second most powerful, third most, and most powerful. Therefore, by making this greater than or equal to 1, we know we'll have at least one of these, if not more. As you'll see, we only end up buying one of them. Let's run problem 3, month 3. I believe we're going to buy 1 SGI for a cost of 10,000. Yes, so we buy 1 of server type 3 being the SGI. Cost is 10,000, supports 200 people. Perfect. This supports our 200 people. We now have bought the 2 PC standards in month 2, 1 SGI in month 3. Let's move on to month 4. Month 4, here's our minimization function, the exact same as month 3. No discounts being applied. Here's our constraint. We need to support 30 new people, as the warehouse now needs support. These 30 new people, we run this. Again, I don't need to explain this too much. It's the exact same as month 3, just with this different value here, as we're supporting 30 new people in this month in a vacuum. Let's run month 4. I believe we're going to buy 1 PC standard for a cost of 2,500. Obviously, 1 PC standard is X1, 30 people, 30 times X1 being 1. Yes, so X1 is 1, cost of 2,500. That supports the 30 people in month 4. Let's check out month 5. Again, the exact same as month 3 and 4 in the minimization function. We're now, there's still no discounts being applied as it's the 5th month. We're now supporting 75 new people as the marketing department needs support. So again, I don't feel like it needs too much explaining. It's the exact same as month 3 and month 4, just with this different 75 value. Let's run month 5. I believe we're going to buy 1 PC enhanced, which will support 80 people. So we have an extra 5 slots, but it's still minimizing the cost. So it'll be a cost of $5,000 buying 1 PC enhanced. So in total, we bought 2 PC standards, 1 SGI, 1 PC standard, and then 1 PC enhanced on a month-to-month basis for a total of 3 PC standards, 1 PC enhanced, and 1 SGI for a total cost of $22,500. This was on a month-by-month basis, supporting enough employees per month. As the problem states in Part B, we move on to realize that perhaps it'd be more cost-efficient to, in earlier months, buy larger servers to support employees in later months. So I then created this model, and this will take some more explaining, I guess. But essentially, what the case is that we're now looking at it as a big picture instead of on a month-by-month basis. And so I now have 20 decision variables here. And these decision variables represent X sub ij, where in server, we buy server type I in month J. For example, X11 is buying server type 1, which is the standard PC, in month 1. This would be buying server type 1 in month 2, so on and so forth. For example, X35 would be buying server type 3 in month 5. So kind of the point of this is that each server costs a different amount each month, as well as when we were in month 4, what we bought in month 1 and month 2 and month 3 still matters. We still have that server. It's still supporting enough employees. So we feel that there's going to be a more efficient, more cost-efficient way to buy these servers early on, especially with some of the discounts that are applied. So in this minimization function, what I'm minimizing is, again, the total cost. There are a couple of different terms here, so I'll explain each one. This is minimizing 2,500, which is the cost of server type 1. There are never any discounts to server type 1, which is the PC standard. So these 5 decision variables are the 5 variables of when we buy server type 1. This would be buying it in month 1, buying it in month 2, buying it in month 3, etc. It always costs $2,500 no matter the month. This is for server type 2. Always costs $5,000 no matter the month. Server type 3, there's a discount in the first 2 months. Costs $9,000 in the first 2 months for server type 3. Costs $10,000 in the next 3 months for server type 3. So month 1 and month 2, month 3, month 4, month 5, and there are costs for that. Similarly to server type 3, here's server type 4. It costs $18,750 in months 1 or months 2. It costs $25,000 in months 3, 4, or 5. So again, we have these two separate kind of clauses, groups, depending on the price of when we buy that server. Because again, the first number here is the number of the server type 4 in month 1, costs different than server type 4 buying it in month 3. There are discounts in the first 2 months. Next, let's move on to the constraints. So constraint 1 is the number of employees in month 1. Again, similar to earlier, month 1 requires 0 employees. So this is buying server type 1 in month 1, server type 2 in month 1, server type 3 in month 1, plus the amount that server can support, must be greater than or equal to 0. So this is the constraint for month 1. Month 2, what basically we're doing is what we bought in month 1. So if we bought any of server type 1 in month 1, bought any of server type 2 in month 1, if we bought any of server type 3 in month 1, those still matter. We still have those servers. Again, we're looking at the big picture. What then also matters is if we buy any of server type 1 in this month, in month 2, any of server type 2 in this month in type 2, and if server type 3 in this month being month 2. Obviously multiplied by the number of people that server can support. And now in month 2, we have 60 people, being the 60 sales staff that we need to support. In month 3, as we move down, we now have 260 people. It's the total amount of people that we need to support before and into month 3, being 260, sales and manufacturing. So this is the amount of people that type 1 can support, plus whenever we bought server type 1, amount of people that server 2 can support, times whenever we bought server type 2, amount of people server 3 can support, whenever we bought server 3, etc. Constraint 4 and constraint 5 are basically the exact same as the previous few I just mentioned, just adding on, extrapolating for the future months. So constraint 4 is for month 4. In month 4, we had the prior 260 people plus 30 new people. I think from the warehouse it was in month 4. Let me check. Yes, 30 new people from the warehouse for 290 total. So we have 290 people here that need support. Again, multiplying the amount of people that server 1 can support times whenever we bought server 1, amount of people server 2 can support whenever we bought server 2. Similarly for constraint 5 being month 5. However, now the value is 365. This is all of the employees that need eventual support being 365. Also notice how, that's basically all I have to say about that, is the number of employees in month 5 is 365. It's a 75 new plus every employee prior that needed support. The last 2 constraints are some of the other constraints that were mentioned in the problem. We had a budget of $9,500 to spend in months 1 and months 2. So we list the costs for these servers in months 1 and months 2. Obviously, these 2 have discounts. Must be less than or equal to $9,500. We're multiplying these costs by whenever if we bought server type 1 in 1 or 2, if we bought server type 2 in month 1 or 2, server type 3 in month 1 or 2, server type 4. That total cost needs to be less than $9,500 for months 1 and 2 total. Lastly, manufacturing needs one of the 3 stronger servers. Manufacturing needs service starting in month 3. Therefore, before or in month 3, we must buy at least one of the stronger 3 servers. These being server type 2, server type 3, or server type 4. These 3 phrases here will be buying server type 2, 3, or 4, the 3 strongest in month 1, which is obviously before month 3. These would be buying it in month 2. These would be buying it in month 3. This must be greater than or equal to 1. So these are all the constraints. When we run this problem, we're going to get a total cost of $19,000, I believe. There we go. Solution with objective 19,000. The total of cost is 19,000. Remember, this is now $3,500 less than in part A when we went month by month. Let's look at what servers we buy. We decide that in month 1, we buy server type 3 in month 1, which at that point in time costs $9,000, which is less than $9,500, supports 200 people. We're going to be good for a few months supporting 200 people. Then in month 3, so then we buy server type 3 in month 3, which again supports another 200 people. Now it costs $10,000. This is for a total cost of $19,000, supporting a total amount of 400 people after month 3, which again is fine. In month 3, we need 260. Month 4, 290. Month 5, 365. We're supporting up to 400. We even have extra room to hire some new employees if we want. This basically all makes sense with minimizing costs as well as supporting enough employees. So that is pretty much my solution to this problem, problem 3, I um, show the code and the answer to each specific question. I guess for the answers to the other questions about, I think some of them being, why is the answer to the first method different? Well, as I stated earlier, the first method we're going month by month, whereas the second method we're looking at the big picture and we're minimizing the total cost across all months, where what we buy in prior months matter in this month, whereas prior in part A it was just on a month by month basis. What other costs? There will also be other costs such as installation fees, training fees for the employees for the new system. Um, what other concerns might departments have? Well, they might be concerned with just their change of their way of business and their day-to-day tasks being different now using this new system. Um, there also might be concerned with um, why these server prices were justified. It may be confusing as to why we buy a big server early on when we don't need to support these people. All of it is justified by our constraints and by our problem statement here, by our linear optimization, linear problem, but linear programming model. But they might be confused as to why that. So they might have concerns about that. So I'm going to end this recording and stop recording and put this link on YouTube. This is for problem 3 of exam